Hey everybody, welcome back to chemistry. So if I can blow up the slide. So this question is regard to Lewis structures that you need to draw. So they want you to draw the structure of bromous acid, which is HBrO2, and then it says optimize formal charges. And then we're going to do another one. It says draw the structure of periodic acid, which is HiO4, optimize formal charges. So if I can lower the slide. Okay. So what I'm going to do is I'm going to do bromous acid first. And so I will write out a first Lewis structure. But as you'll be able to see, there will be other Lewis structures that I can draw that are perfectly good. So I'll have, say, 3 or 4 Lewis structures on the board. And what they want you to do is figure out which one is the best one, which is the lowest energy one. And the way you figure that out is you figure out the formal charges for each of the atoms, and you decide based on formal charges which structure will be most represented in the final structure. So let me go ahead and get up at least one Lewis structure here for this molecule here, bromous acid. So let me go ahead and just, let's figure out valence electrons first. So bromine has 7 valence electrons, and then there's oxygen, and there's 6 valence electrons, and there are 2 of them here with a total of 12 electrons. And there's hydrogen here with 1 electron. And so it looks to me, it looks like we have a total of 20 valence electrons. So that will be 10 pairs of electrons we have to deal with. Okay, so let me go ahead and draw a skeletal structure for this molecule. So bromine is going to be in the center, because between bromine and oxygen has a lesser electronegativity. And so we have to put oxygen on the outside. We can put 1 here and 1 here. And then you have to remember that hydrogens are always terminal. So you have to have a hydrogen that's going to be outside of an oxygen. So we'll be here. Okay. So let's go ahead and put in the 10 pairs into this molecule. And so the first pairs, as you know, will bond atoms together. So I'm going to draw a pair of electrons as a line when I'm needing a bond. So 1 pair, 2 pair, 3 pair. Now I'll add in lone pairs. 4, 5, 6, 7, 8, 9, 10. Okay, so this is a perfectly good Lewis structure. And so what I'm going to do is I'm going to write some more perfectly good Lewis structures. And so there are a couple of things to keep in mind when I do this. So first off, we have oxygens here. All oxygens must have 8 electrons. Bromine is, I think, in the 5th period, so it can have more than an octet. So one other structure we can make, if we want to, is we can move this lone pair here on oxygen to form another bond between oxygen and bromine. So let me go ahead and draw that out like this. So this is a perfectly good Lewis structure, and so let me explain why. This oxygen still has an octet. This bromine no longer has an octet, but is now up to 10 electrons. And so again, bromine can have more than an octet. Okay, so this time what I'm going to do to make another good Lewis structure, you see this lone pair on the right oxygen? I'm going to take that away and form a bond there. So let's see what we get from that. So we get this. This is another perfectly good Lewis structure. Okay, so I'm going to draw one more. So if you wanted to, you can move this pair into the bond here, but at the same time move this pair into the bond there like that. So let me draw out this resulting Lewis structure. So now it looks like we have 4 Lewis structures. So all the ones I have drawn are perfectly good in that oxygens all have octets, hydrogens have duets, and the bromine can either have an octet or maybe have more than an octet. So here, this bromine in this structure has an octet. Here it has 10 electrons, here it has 10 electrons, and here it has 12 electrons. And so that is acceptable for bromine. However, there is one structure that is probably going to be better than the rest, in the sense that it's going to be more represented in the final molecule. You'll see more of its structure in the hybrid structure. So how do you identify what the best structure is? Well, you have to assign formal charges to each of the atoms. and then analyze the structures. And so let me remind you how you figure out formal charge. So formal charge is going to be equal to the number of valence, I'll just write val for valence, electrons minus dots plus lines. So I think I explained in more detail why formal charge has this formula in an earlier PlayPosit. So let's go ahead and apply this formula here and just go ahead and assign formal charges to each of these atoms. Okay, we'll start out first with this oxygen here. Let's figure out its formal charge. So this is how I would calculate it. So oxygen, you can look at its location in the periodic table and you will see it has 6 valence electrons. So I'm just going to write 6 here. And then I'm going to subtract from it the number of dots and lines. So there's 1, 2, 3, 4, 5, 6 dots. And then there's 1 line. So it's 6 minus 7. It's going to be equal to -1. So I can give this oxygen a formal charge of -1. All right. So let me go ahead and do the bromine here. I'm going to do it in a similar fashion. So bromine, based on its location in the periodic table, has 7 valence electrons. And let's see, how many dots does it have? It looks like it has 4 dots, and it has 2 lines. And so it's going to be 7 minus 6, which is going to be equal to +1. So we're going to assign this bromine here a formal charge of +1. This oxygen, you can do a formal charge calculation. It's 0, and you can do the same thing for this hydrogen, and it's 0. So what I'm going to go ahead and do now is I'm going to go ahead and assign formal charges for all the atoms in the other structures. So I'm going to go ahead and do that now. Okay, so I have gone ahead and assigned formal charges to each of these atoms in each of these structures. And so we have 4 Lewis structures here. They've all been drawn correctly, but again, as I was saying, one is going to be considered the best structure or the lowest energy structure, and you have to identify which one it is. So there are a lot of rules that you should know for discriminating which Lewis structure is the best one, but perhaps the most basic rule is the Lewis structure where the atoms have no formal charge compared to Lewis structures where there are some kind of formal charges like -1 or +1. The ones with no formal charge, in other words, the atoms have 0 formal charge, those are the best ones. And so you can see of these 4 structures, 3 of them have atoms with some kind of formal charge, a -1 or a +1. But there's one here that has all the atoms with 0 or no formal charge. It's this one. So this is the structure that your achieve assignment wants, okay? So we now will move on to another molecule. Okay, so the next one we're gonna do is we're gonna draw several Lewis structures for periodic acid. So they will all be correct, but we're gonna have to figure out what the best one is by assigning formal charges to all the atoms, to all the different Lewis structures. So first, let's get up one correct Lewis structure. And so you figure out valence electrons first. And so here you have iodine, and it has 7 valence electrons. And then you have oxygen, and it has 6 valence electrons. And there are 4 of them, and there are 24 electrons here. And then you have hydrogen, and it has 1 valence electron. So it looks to me that we have a total of 32 valence electrons and 16 pairs. Okay, so let's go ahead and draw a structure for this. And so, okay, between iodine and oxygen, iodine has the lower electronegativity, so we're going to put that in the center of the structure. So we'll have iodine here. And then I'm going to put oxygens on the outside like this. And then I'm going to have hydrogen on one side like that. Okay, so we have 16 pairs, and so the first pairs I'm going to use to bond atoms together. So 1 pair goes here, 2, 3, 4, 5. All right, the rest are lone pairs. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so this is a correct Lewis structure for periodic acid. However, you can draw several more correct Lewis structures. So let me just give you an example of one. You can move, say, this pair of electrons here into this bond between oxygen and iodine, and you're allowed to do that because after you move the pair of electrons, oxygen will still have an octet. Iodine, which now has 8 electrons, will be bumped up to 10 electrons. And because iodine is not a second period element, it's further down the periodic table, it can accept more than an octet. So you're allowed to do that. So what I'm going to do right now is I'm just going to write out a bunch of the major other correct Lewis structures you can draw. Okay, so what I've done is I've drawn out 5 correct Lewis structures, A, B, C, D, E. So let me point out some differences between them. So one thing you might notice is that structure A has single bonds between all the atoms. Structure B has mostly single bonds, but with a double bond between oxygen and iodine. Structure C has 2 double bonds between iodine and oxygen. Structure D has 3 double bonds. And structure E has 4 double bonds between iodine and oxygen. So what this is going to do is going to change the number of electrons that are associated with iodine. So in structure A, iodine right now has an octet. In structure B, it has 10 electrons. In structure C, it has 12 electrons. In structure D, it has 14 electrons. And in structure E, it has 16 electrons. Iodine has a lot of electrons on it, but that is okay because iodine, as I recall, is in period 6, and so it can accept a lot of electrons well beyond an octet. Okay, so one of these structures is going to be preferred over the others, and the way we figure that out is through formal charge. And so I have the formula there for formal charge, but I'm just going to go ahead and put in formal charges into these molecules. Okay, so I have correctly assigned the formal charges for all the atoms on each of these Lewis structures. And so there is, again, that predominant rule about formal charge in that the structure where all atoms have no formal charges on them, in other words, the formal charge is 0 for all atoms, is the preferred structure compared to other Lewis structures that will have formal charges. And so what you can pretty much see is that structures A, B, and C and E all have formal charges, but structure D does not. So the answer they want for your homework, achieve, is structure D. Okay, thank you for listening. We'll see you next time.